be fully installed. That's right. We're going to be able to use HIP to access the AMD GPUs in Photonics. So HIP is very similar to CUDA, and what I'll be working on over the next few months is a course that is equivalent to the OpenCL one, but for HIP. So that's what I'm working on at the moment. But while I'm here in Victoria, I'm also got my telescope again, and I'm sort of running a side business doing sky tours for folks down here.
Oh, that sounds like a lot of fun.
Yeah. Yeah. So that's what I'm working on with Pawsey at the moment.
So who's using Acacia at the moment?
I haven't started setting it up yet because I'm still setting up my cluster, which has been a little bit of a pain in the butt. So I'll be going on to Acacia soon because my project's in genomics. So I'll have a lot of big bits of genome data to put through.
Yes.
I've got about 95 plant genomes that I'll be storing on there. Okay. That I can like move in and out between my instance. I guess my question is it relatively easy to set up? I've had a brief look at the documentation. It's mentioning a MinIO client.
Yep, that's right. There's 2 clients at the moment that we're sort of recommending. There's the rclone, which is kind of like a more updated brother to rsync. And then there's the MinIO client, which is a proprietary tool developed by MinIO for their object storage, but their object storage talks S3. And so Acacia uses S3 as its middle language. So we can use the MinIO client to talk to Acacia as well as rclone. So both rclone and MC, they both use the S3 protocol.
So I could use either one essentially to set up Acacia. Okay.
What we found during the training modules that we delivered recently with Acacia is that you kind of have to use the best bits of both clients. So for example, rclone handles synchronization of directories. It seems to handle synchronization of directories a bit better, but MinIO client handles things like metadata better. So you've got to mix and match the 2 clients and leverage the best of either for what you're doing.
Okay. Yeah. Thank you.
Yeah. Just a question for you, Brittany. You mentioned a cluster. Are you setting up like a Nimbus instance, or how's that working for you?
So for my instance, I have 3 instances. They're all a 64 gigabyte RAM flavor. And so my master node is also 64 and my 2 worker nodes.
Yes.
And I've mounted, I think, 600 gigabytes of volume storage onto my master node, but I'm going to like float that over the other 2 as well, so they can kind of access it all together. I think it's through NFS. I haven't set that up yet though. And I'm setting up a Slurm managed cluster on my instance.
Nice.
Yeah.
Wow, that should be a lot of fun to set up.
Yes, it is.
Yeah, I recently tried setting up Slurm within like a Kubernetes kind of environment. So that was a lot of fun. Got to make sure the keys and accesses are okay and everything else like that.
Yeah.
So I think Pawsey does have some documentation, but I think you could go to the portal, so portal.pawsey.org.au, and they've got, when you set up your Acacia access keys, they've got like example configuration files that you can just copy and paste into the rclone and MC config, and that'll get you configured quite quickly.
From my experience, it was literally a copy
Yeah.
and paste. So it's sort of, once you have MinIO client or rclone installed,
Yes.
they've kind of done the rest of the work for you in terms of the setup.
Yeah.
Fingers crossed, but it's gone well for me when I've tried it.
Yes.
Okay, so it's just a matter of like pasting those config files into the right directory and then initiating, I'm guessing, like an install bash script or something, or
so installing the software, and so once you can use that in the command line, it's copy and pasting a command, so you don't even need to navigate. And it's
awesome. Yeah. Cool.
I also have the training material that we could give to the students as well, Edric. Are you guys comfortable with that?
Sounds great.
Yeah. All right. So I'll just copy the link. Copy the link to the most recent training material. Now that's currently hosted on Acacia, so we're using the URL functionality on Acacia to hold the course material, but we should have this on GitHub sometime soon. But yeah, if you click on that link that's in the chat, you should have acaciatraining.zip. And so that's got a number of HTML files and a few PDFs just explaining what Acacia is and the tutorials. So I'm not sure if Pawsey wants to take you guys through the formal training associated with this material. But that's what we've been doing over the past few months, just to get people onto Acacia.
So our approach so far has been to work with the interns, setting up their access and sort of answering questions as they arise. So we've had a pretty intensive first week of training. Haven't quite cracked the nut of figuring out where we will fit Acacia into the week.
Yep. Yeah. Did you go through the training modules, the PDF training modules that for the user documentation that Pawsey has?
Yeah, so intro to supercomputing.
Oh yeah. Yep.
So they've done the intro to supercomputing, a Unix workshop, version control.
Yep.
The kind of core.
Yeah. Using Git and things like that. Yeah, cool.
How to protect your work from your dog.
Yep. Exactly. Hey, I'm curious. It was fascinating to learn what you're doing, Brittany. What is everyone else doing with their projects? Keen to hear what you'll be doing.
So yeah, can you hear me?
Yep. Hey, Daniel.
Hello. So my project is to help development team of Deluge workflow system. I don't know.
Yep.
Yeah, I'm familiar with this. So that's Andreas Vasinek in the of the team.
Yep.
So my work is to help them with the development, and right now my task for the next few weeks will be helping them with the benchmarking of the Deluge system by using Sotonix. And particularly measuring how the Deluge system will work on Sotonix and communicating with Acacia. So I haven't done the setup yet. Also, so I feel pretty comfortable because I should have tried this, but yeah. So I had only 1 week to get myself comfortable with the system. It's really huge, so that's a big project.
Yeah, no, that's really cool. In that case, for your specific instance, I might look into using Boto. So that's I think that's Amazon's S3 client. It works with Python. So Deluge is a Python based
Yes, that was my plan.
Yeah. So I'd look into using Boto. We don't have any training courses for using Acacia with Boto that I'm aware of at the moment. But it sounds like for your use case, which is a bit lower level, yeah, I'd recommend Boto, having a look at that.
Yes, I'll definitely have a look at it.
Yep.
So, yeah.
Yeah.
Thank you for insight.
Yep.
Might be a little cheeky and ask a question for my own work off the back of Daniel's. So the work I do, I generate a lot of just HDF5 files using a program that uses a Python interface. So with this package, by the sounds of it, I could just set up in Python backups to Acacia just as part of my workflow.
Yes, Boto. So for most people, maybe Brittany's wanting to just upload files. You could use Boto as well if you wanted to, Brittany. But if you just wanted the simple, I just want to get files up and down to Acacia, then MC and our clone are for you. But if you want a library that interfaces with your programs, then I'd suggest using Boto.
Okay,
Well,
cool.
yeah, especially if you're going down the Python route, if you've got any Python applications that you're working with, that'll dovetail nicely into that.
So is Boto like another interface that is used to communicate with Acacia, but it has a little bit more flexibility, so you can have it integrate with your programs as well?
Yes.
That are on, say, installed on Nimbus.
Yep. Yeah, it's got so I think Boto is a Python package. So that's just a package that you can import into your Python program, and that works with Amazon. I haven't actually used it myself, but I know that that's probably what I would use if I was trying to integrate Python with Acacia.
So like the unifying property of all of these approaches is just that they're compatible with the, is it like the S3 protocol or standard?
That's it. Yes. Yep.
Is that standard open source or?
I believe it was developed by Amazon because they've got their S3 storage service. So I don't know how much of that is open source. But I think the standard itself is used by lots of people, so I don't think Amazon has an issue, people using the standard or implementing tools that work with the standard.
Yeah, by the sounds of it, they must have a really nice API and documentation and so on to have all of these different solutions.
So Boto 3 is the Python package. Yep.
So the sort of the advantage that I can see with something like Acacia is that it's accessible across all of Pawsey systems. You can access it on your laptop. You can give links to people.
Yeah.
So that's definitely I can already see how that's an improvement.
Yes.
But what else? What other motivations does a sort of a supercomputing center have to adopt this sort of warm storage approach?
Yeah, I think the prime motivation is preservation of the Scratch file system. I think from the supercomputing perspective, because you've only got 15 petabytes of storage on Scratch at the moment, and that's really high performance storage. But if folks store all their data, then it's going to fill up pretty quickly. So Pawsey has a file reclamation policy where if you don't access a file for 30 days, it gets deleted. So that's what Acacia is for. Acacia is to provide, that mid to long term data storage for your projects. And with the training course that you have access to in that link, there's ways whereby you can incorporate Acacia into your batch scripts. So if you're using batch jobs on Cetonics, you can, for example, use the copy queue to copy things from Acacia, then you do Scratch, then you can do your work on the data in Scratch, and then copy things back to Acacia using a copy queue again. And if you use the copy queue, then the time that you spend copying won't count towards your allocation. So it's yeah, so you can copy things for free essentially. But as you were saying, Edric, being able to share links with people like we've just done is really, really helpful. So you can share data with colleagues and things like that, so they can access, your data from outside. So yeah, it's kind of like a central storage service that everyone can hook into. Yeah. So I think makes it more useful than HPC file systems have been in the past. But as far as what we how we think of Acacia, it's kind of like you have to transfer files using HTTPS requests. So just think of it like as a web storage location. So that's how you've got to work with the system, is using uploads and downloads. So you can't access data live in the sense of being able to open something, modify, and then close it again. You have to pull data down from Acacia, do something, and then push data back up. So that's a fundamental, one of the fundamental differences that Acacia is from a HPC file system.
Sort of the idea of, once you've created uploaded files to a bucket, those those files are sort of frozen in place.
Yeah. So you've got your storage allocation. So you've got your personal storage allocation, and then your project storage allocation. So I think you get 100 gigabytes for your personal storage allocation and a terabyte for your project. And yeah, so that provides the storage, and you can get that upgraded if you need to. Yeah.
Another question I have is, have you come across anyone who's wanted to, say, transfer files from a Google Drive over to Acacia?
Oh,
is there a way to do that? No, not so far.
Well, I guess, yeah, there would be ways to do it. I think there is a Python interface to a Google Drive if you wanted to have a look into that. But I guess I would maybe just synchronize the files to a local system. I mean, how much data have you got, Edric?
Well, so I think I'm talking about a project that I've come across this year. So I think it's in the hundreds of megabytes. So not huge, but the main concern's the security, right? So
right.
If there was a way to, they could synchronize it, I guess, with their local machine and then upload to Acacia. But if there was a way to just do a transfer directly from the Google Drive hosting to Acacia, that would be the most secure. But it seems like using, it could be a little complicated, but using the Drive, Google Drive Python API, whatever, or package, and then something like that Acacia package would probably let you do that in a single Python script. But
yeah, a few hundred megabytes isn't really an issue, I suppose. But if they were, terabytes or so, then yeah, you'd have to explore something.
Actually, I have experience of using Google Drive, and I mean, with my own file system. And as far as I know, there is a really good interface to manage Google Drive from Google Colab.
Okay, cool.
Yep. So I used the thing for my ML projects.
Yep.
And yep, so there is a so you can just mount
Yes,
your
you can
Google
mount your Google Drive.
in Google Colab project.
Yep.
And then that just a matter of Python to synchronize things with Acacia. So I don't know. So just to
Yeah, that's a valid way to do it too. Yeah,
it's a nice suggestion. Yeah,
good
maybe you could
suggestion,
use Bodo 3 in a Colab notebook to
yes.
Yeah.
and mount Google Drive there. So,
Yep. Hey, I'd like to hear about the other projects as well. So Akbar, Abraham, Yutakan, and Sam.
Oh yeah, so my project is about creating a deep learning model for IoT devices, which like for classifying sensitive information. So the idea is that we want to like reduce the amount of sensitive data that's being sent to the cloud from IoT devices. So yeah.
Oh, that's cool. So are you doing inference at the edge, are you?
I haven't decided on the architecture. Probably like something like in the edge, because like you know, if it's starting to cloud, then what's the point anyway?
Yeah. Yep. So that's applying the machine learning model on this really low power hardware that's at the edge of your network.
Yeah, something like that. Probably.
Yep. No, that's really good.
So for my project, it's mostly to develop a digital twin engine. So right now we are focusing on red meat industry. So at present, like because there's a whole lot of lack of data. So the first milestone for us is to create a data set so that we can actually manipulate the process line and on the basis of a machine learning model. So yeah, that's the idea.
Okay, cool.
Yeah.
Yep. How about you, Abraham?
Hello. Well, I am working in machine learning. Specifically, I'm trying to modeling stress corrosion cracking. It's a specific form of material degradation for alloys utilized in oil and gas production. And well, actually, we are for this internship. I'm just trying to model or create an XGBoost model for a classification model that I'm going to compare with another modeling approach called Bayesian network. So given that both approaches are kind of similar because they can give you insights about how the variables can interact each other, you can compare the results and the connections between the Bayesian network and also between the future importance into the XGBoost model. So the great challenge in here, well, for the internship is just using photonics. I don't know if I have to use Acacia, but it's just using photonics for hypertuning and also cross-validation, which can be very time demanding for that kind of modeling model.
Yep. So I guess will you be using the GPUs, or is this a CPU based machine learning framework?
Yeah.
Using the GPUs?
Yeah.
Ah, cool. Yep.
Yeah, only that. It's not, well, maybe it's not so robust as other projects. The only challenge here is just make my code a little bit more efficient.
Yes.
And reduce the time for finding the solution to the XGBoost model, which can require, I don't know, more than 4 days for converging the solution.
Right. Well, I guess once you get access to those MI250s, yeah, you might be surprised as to how good they are.
All right.
Cool. Last one. You did come. Sorry, I don't know if I'm pronouncing your name.
Yeah. Daniel's fine.
Oh, Daniel, cool.
Yeah. It's just about the project, right?
Mm-hmm.
Sorry. Just like before, just a bit ago.
Yep.
Yeah, my project's been looking at marine biofilms, which has been well, trying to get metagenome samples from the data, which has been 400 gigabytes of just reads from samples.
Yep.
Yep, but I haven't used Acacia yet.
Okay.
For it.
Yep. Yeah, it sounds like you might be wanting to upload to Acacia at some point. And how big is each file?
All compressed, it's 410 gigabytes or so, I'm pretty sure.
Yep.
I'm doing all the work on Cetonics. And so far, not all the data is up there, but it's going up slowly.
Yep. I think you might encounter an issue with large files uploading to Acacia. So what's going on with the S3 protocol that we use to talk to Acacia at the moment is that they do, MC and rclone, they do uploads in chunks, and these chunks are 5 megabytes in size, and you've got a fixed hard limit of 10,000 chunks. So unless you increase the chunk size, you're limited to a file size of about 50 gigs. So there is, if you look in the documentation that we uploaded.
Yeah, I think it'll be okay. It's split across 72 files, so they're not more than a couple of gigabytes in size.
Right. Yep.
Yeah.
Oh, that's all right. So if anyone is working with large single files, you just have to be aware that you're going to have to increase the chunk size with rclone. I think you can do it with rclone. You can increase the chunk size in your config file. So I'll just I'll share my screen. Yeah. So this one here is, can everyone see that? So this is an example config file for rclone, and you just have to add this extra line here. Chunk underscore size is equal to 1G or 1 gig. And that'll increase your maximum allowed file size that you can upload to just under 10 tebibytes. So that might be helpful just when you're working with large single files. But you might be, yeah, it looks like you're under that limit, Daniel, so that's okay.
Yep.
With your files, Brittany, do you have lots and lots of small files?
The current files that I'm going to import are, I think the whole size of all of them, but they're all compressed, is like 95 gigabytes. So I don't think it's going to be too much of an issue.
Right.
But they're 95 smaller files, so they're the raw genome data. Yeah.
Okay. Yep. Yeah, I'm just aware sometimes with genome data, it's sort of lots and lots of smaller files, but it sounds like yours is quite manageable. Yeah, the only thing I was going to suggest is sometimes, because every upload to Acacia is its own little HTTPS request, if you're transferring lots of little files, that can be very slow, but you could use tar to, compress or, concatenate those files together into a tar archive. And then you can upload that tar archive to Acacia that way. Yeah, so that's just one way of optimizing things a little bit.
I think it's related to the idea of optimal file transfer. How does, if you're writing your code normally, you'd be taking into account how often you're writing your results to disk, right? Because that can be a bottleneck. Now, are there any special considerations or additional special considerations if I'm working with Acacia? So am I able to say, do I have to write from, say, scratch to Acacia, or am I able to just write directly from memory, like upload from memory to Acacia?
Yeah.
How should I chunk my uploads?
Yeah, I think there would be ways where you can send a stream, so standard out directly to Acacia. The rclone rcat method, so the subcommand in rclone called rcat, that allows you to send an output stream to Acacia directly. So I guess the answer is yes. you can stream from memory straight to Acacia, but that's pretty advanced. I guess what I would suggest, though, as a first pass is just to write to scratch first, and then when your job's finished, then you can upload. Yeah, because the streaming approach is very fragile. Streaming. I mean, you can even tar stream files up to Acacia, so you can tar on the fly and send that stream to Acacia, so you can avoid a middleman tar file. I would only recommend streaming if you're on the Pawsey network. So if you're on Cetonix, yes, you could try streaming direct from your application, streaming direct from Cetonix. But I wouldn't recommend streaming from outside to Acacia. There's just too much potential for something to go wrong.
And the sense I get as well is that in general, maybe only be interested in doing something like streaming directly to Acacia if I was doing work that had a decent chance of, say, taking up my Scratch allocation. Yeah. So like, aside from that, working with the super fast Scratch storage would probably always be the ideal thing during your actual production run.
Yeah, I believe projects have a 2 petabyte limit. So yes, I don't think your Scratch allocation is in, something that's going to be in danger.
It'd be in a very pretty extreme case.
It would be an extreme case, yeah. Yep.
Cool. Does anyone have any questions, say, even just about the inner workings of the storage system? Just, idle questions or shower thoughts. It's a good chance to bring them out into the light for discussion.
Sure. And if the questions are too advanced, I'll just duck for cover like this.
Good to have a plan.
Yeah.
I have a very basic question. Sorry, was someone asking a question?
No, it's all right. Go for it.
So the buckets, how do they work? So if I was to make a bucket, would I put, say I had a project, like a separate little project within my bigger project that I wanted to work on, and I had a certain data set, would it be a good idea to just stick it in that bucket and then I can upload that bucket directly to Nimbus and then I can just put it back? Is that how it works?
Yeah, so a bucket on Acacia is kind of like your first level folder in a file system. Acacia doesn't let you have any further levels of folders. But instead, what you can do is you can append or prepend a folder to the object name. So you can prepend the name of a folder with the / to the name of the object. It's still flat storage, so everything is flat storage within a bucket. But that's how you can replicate the hierarchy in a file system, is just by append or prepending the folder or subfolder names to the name of the object.
Okay.
Yeah.
So I'll have like multiple objects within Acacia, but then if I prepend those particular, like making it almost like a little directory path.
Yes. Yeah.
Yeah. Okay.
Yeah, you can add those directory path names to the name of the object itself. So the object is inside a bucket, but you can muck around with the name of the object such that it replicates a hierarchy.
So I can have multiple objects inside of that bucket, and then I can have my hierarchy. Okay, that makes sense.
Yeah, so you can, your hierarchy sort of emulated, as it were.
Yeah.
So just to be clear, it remains flat storage.
So they're not technically within another. They're all still on the same level, but you can kind of create an organizational flow, I guess.
Yes, you can create an organizational structure by mucking around with the name of the object. Yeah, so that's prepending folder names to the name of the object. Yeah. Okay. But if you're going to make a separate project, you could easily make a separate bucket. So you don't have to have one bucket for everything. I think you can have up to 1,000 buckets.
Okay, cool.
So that's that's quite a generous.
Yeah, more than enough available.
Yep. But the thing is, the buckets, their names have to be unique across the system. So someone if they call their bucket, Acacia Project X, and then someone else can't call their bucket Acacia Project X. And
I have a question about like the genomes again. If I was to want to transfer over them all individually, like the 95, they'd become all separate objects, right? Within Acacia.
Each an object is kind of like a file. So an object is kind of like a file, but it has extra things like metadata that you can attach to the object. Yeah. So that's, so we think of an object as being a file with ++ attributes. Yeah.
If I was to transfer the files directly like that way, would they still maintain the same file names, or would I have to like modify them all to have the same file names that they had originally when I transferred them?
Oh yeah. So if your file names are unique within a file system, you could easily just synchronize the whole hierarchy or the whole subfolder structure. You could synchronize that to a bucket.
Oh,
and
awesome.
rclone and MC would append or prepend the subfolder names to the names of the objects.
Oh, so you can do that with a command through the client automatically. So I can just say I want it to prepend all of the names of the files to the objects.
Yeah, I think so. There's an rclone in the documentation. There's like an rclone sync or synchronizer directory. So that would be the way to do it, is that you could just synchronize an entire directory to a bucket. Yeah.
Cool.
Yep.
So like if I had my software set up finally on Setonix, I was very happy with how it was all working. I could use rclone, for instance, to create a backup perhaps of my software directory if wasn't too large.
Yeah, you could. So just keeping in mind the fundamental principle that every file copied is its own connection to Acacia. So if you're transferring lots and lots of little small files that might be in a software directory, then that's going to take quite a long time. It might if you're backing up your software, it might be better just to tar everything, and then upload that tar archive. When you're doing synchronization of directory structures, because the hierarchy is emulated, of course, empty directories don't have any meaning within a file, sort of a file name. So only concrete, not concrete, but only actual files will be transferred across. So empty directories won't be replicated in Acacia.
And I guess like a bit of a curveball. What if you had like a symbolic link?
Yeah, symbolic links won't be. Yeah, they won't make it across either. I think you might have to follow symbolic links.
Mm-hmm.
Yeah.
So I guess it's sort of, if you're synchronizing a directory for your actual results, right, or some code, we're talking probably usually about hundreds of files, maybe.
Yep.
But then a software directory is easily going to run into thousands of very small files.
Yes, that's correct.
So that's when you're in that territory, that's when you're much better, as you said, making an archive.
Yes.
Loading.
Yes, that's right. I think there is a limit on the number of files you can have.
I could imagine being able to.
Yes.
You'd hit that limit if you just wanted to, back up a whole bunch of packages and.
Yeah.
Yeah.
Yep. I've just got the documentation up, and I think it's 100,000 files. Yeah, so no more than 100,000 objects per bucket, after which performance will degrade. So there's a hard limit of 1 million objects per bucket. But yeah, you don't want to approach those limits. So yeah, if you're dealing with lots and lots of little small files, I definitely recommend the tar approach, because it'll just save you a lot of time as well.
Mm-hmm.
And you can, if you're dealing with data that you really, 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 really need to make sure that the integrities are all good, you can also use MD5 sums to do a checksum of the file and the source, and then a checksum of the file when it's in Acacia, and make sure that the transfer happened properly.
Is there any resources on how you might perform a MD5 checksum?
Yeah, I think if you have a look in those nodes, there is in T2 Acacia from the command line. It'll be in those notes. Just look for the word checksum.
So that would be so you've just been working for a week, you've uploaded all of your hard
Right.
results. That might be something worth doing.
Yeah.
Or
yep. Yeah,
especially I guess if you're uploading from your local machine, I suppose.
Yep. Yeah, there's a flag with rclone and MC called --checksum. So you can do those checksums if you want to. MD5 sum command. Yes, I'll just go through an example. So I'll just copy this. So this is an rclone command just in the chat there. So we go rclone copy. So copy is the sub command. Data 00.dat is the file name. Acacia mine is an alias. So when you set up your configuration, you will call either the project storage or personal storage, you'll call that an alias. And then you need to have a colon there and then a bucket name. So that will use rclone to copy the data 00.dat to a bucket. And then we've got an extra flag there called -- checksum. So that's a flag that you can have. But what I'd recommend that you do if you wanted to learn rclone and MC is you download that training material and then just work your way through, first of all, L1 introduction, but then the T1, T2, and T3. So they're the tutorials. And they will show you step by step all the different things that you can do with Acacia. So it's a bit like a repository of pre-canned examples about how to work with Acacia.
Very nice.
Mm. Just a question for the machine learning folks. So when you're working with the AMD GPUs, are you using like a machine learning library or are you writing your own machine learning code? So I guess Sam and Abraham.
In my case, I'm using certain libraries for the modeling part. For instance, for the XGBoost, there is a library for the XGBoost.
Yep.
And for the hypertuning and cross-validation, well, it's like a mixed thing because there is just one library for creating the cross-validation and the hypertuning, but the scheme I'm using is a nested cross-validation. So it firstly performs the hypertuning and afterwards the cross-validation. And depending on the first results of the cross-validation is the second loop for hypertuning and then the second loop for cross-validation. So it's a little bit mixed.
Yeah. So would that be eventually using like a ROCm library or a ROCm machine learning or deep learning library?
Learn, I think so, is the only one I'm using.
Yeah. Yep.
And the other one is only that one. I'm not using like another library for deep learning, like TensorFlow or PyTorch. Yeah, actually, my data set is comprised of 20,000, almost 3,000 observations. So maybe it's not like, huge enough for deep learning.
Cool.
Talking about very simple basic questions.
Yep.
So do you know how many times Scratch is faster than Acacia? So like and for what tasks Acacia is faster than not faster, I mean works better, like reading, writing.
I'm not sure. I think with the transfer speeds, so this is both upload and download, you can expect ingest rates to Acacia of about 100 to 600 megabytes a second.
Yeah,
you can optimize this by using, there's a transfers flag in rclone, and that will do, if you're doing multiple files, it will do multiple parallel transfers to Acacia, so you can get quite fast speeds that way. I think, yeah, that's what you can sort of expect.
Yeah.
And Scratch is, as far as I'm aware, like a few gigabytes, or can be a few gigabytes a second. So yeah, probably an order of magnitude slower. That would be the first order approximation. Yeah, probably an order of magnitude slower than Scratch. All right. Well, it feels like we've come to the end of our sort of questions. Do we have any final questions that we'd like to talk over?
If not, Toby, is there any advice or things you wish you knew when you were an intern that you'd like to pass on?
Well, I guess I can talk a little bit about my project. So I had just come out of ANU. I just finished my bachelor's, and as part of the honors year, I was simulating black hole jets. So with black holes from active galaxies, they have these jets, and depending on what sort of what sort of density these jets are spraying into, they either fan out or they stay collimated. And so I was doing that for my honors year, but I came to Perth to start my doctorate, and just in that time before I started, I did a project whereby I was just using MATLAB actually. I was trying to get the radio emission that would be expected from the supernova remnant of SN 1987A. So that's a supernova whose light reached us in 1987. And it's been one of the best observed supernovae in history. And so, yeah, what I was doing is just very simple MATLAB simulations of just assuming that the light from the explosion, or the shockwave from the explosion, sorry, goes out in a spherical shell, and how would the radio emission look like as it, encounters the different structures. So that little sub project was the kernel idea for my PhD. And so maybe these projects that you guys are going to embark on will also be, a topic for further study for yourselves. It might be, or I'm not sure where you are at with your, with your studies. I'm not sure if you're going on to further study, but things like this, they can be springboards for launching off into, a particular field of study. So you guys might become machine learning experts. This might be sufficient for you to get excited about this, to get into, further study, or it might just help you learn how to use high performance computing equipment better. But I guess my encouragement is to use this time just to learn as much as you can. It's not so much, I mean, at this stage, the internship, it's not so much the outcome that's really important, but it's rather all the cool stuff you get exposed to, and the learning process that you went through, what you discovered, and all that sort of thing. So I just encourage you just to use this opportunity to learn as much as you can. And who knows, maybe it will be the start of, you know, future work for you. Yeah. So I think for that little supernova project that I started with for my doctorate, that actually led on to using that that code to simulate black hole jets. I actually used that to simulate, do a CFD simulation now, which is more advanced version of the supernova simulation. I applied some physics for how electrons are accelerated at shocks, and we got a fairly nice comparison between the radio emission from the supernova remnant and then the CFD simulations, which I was doing on IVEC hardware. So yeah, so that was actually a follow-on from my internship project.
Toby, one question.
Yeah.
Do you have any source of, you know, information or for practicing and learning about machine learning or deep learning that you use regularly? Because your project with, you know, is associated with astrophysics. So
yep.
You are analyzing that amount of data, mostly trained or working with significant information, code, whatever.
Yeah.
Which is very difficult to learn, actually.
Yes. I must say that I don't have too much experience with machine learning, but what I do have is a physicist's intuition. So during my PhD, what I was actually doing is I was modifying the initial conditions of the simulation, running the simulation, and then seeing how that compared to the real observations. So the real observations was my objective function. So the difference between my simulation and the real observations was my objective function. So I was kind of like doing machine learning by hand almost. I was changing the initial conditions, running the simulation. How does the chi-squared, you know, statistic work with this? So, but developing that intuition, you know, developing that intuition. So how is machine learning working? So I'm trying to optimize, I'm trying to find the bowl, I'm trying to find the optimal point in this multi-parameter space, right? Developing that insight. I think that's the important thing, because if you can conceptualize your problem that way, then you sort of have that insight, and that allows you to do things that, you know, just an ordinary software developer or, you know, wouldn't be able to do. They wouldn't have that insight. They wouldn't have, you know, the ability to see, oh, hey, if we do this in the Fourier domain, you know, we could do it differently. So combining the mathematics, combining the insight that you get from physics, and combining that with, you know, the matrix multiplications that you're doing in machine learning, I think that's where we have the advantage. Yeah.
Thank you.
Yep.
Nicely put.
Yeah.
Well, we're just a bit past the hour, so unless someone has anything else they'd like to ask, great point to, I think, wrap up. So thanks so much for joining us, Toby. This has been really interesting and informative.
Yeah, thanks guys, and it'd be great to see the outcome of your projects, you know, in several weeks' time. Really looking forward to it.
We'll loop you in the Pawsey Friday internship showcase. It'll be online. You can drop in if you happen to be free.
Yeah, sounds great.
Awesome. And thanks for joining us, everyone.
No worries.
Thank you.
All right. See you, everyone. Bye.
Yeah.
Thank you.